see here. Okay, again in lecture number 1 we start with some introduction. In lecture number 2 we start with the 1D problems. Okay, in lecture number 2 we did some 2D problems. Again in the previous lecture number 4 we solved some 3D problems. Okay, different type of. Now in this lecture number 5 what we are going to do, we are going to solve some truss type problem. Again both some 2D trusses as well as some 3D trusses. And again then we will see some advanced things if we have some non-prismatic type of members. So how we can actually model those type of member in SAP. By non-prismatic, up till now we have just solved prismatic, which have one shape, one type of a shape, for example, for over its whole length, something like this, as you can see. So it has full length here, up from the top to bottom. It has the same thickness, but we could also have different type of other type of non-prismatic member which will have geometry. For example, if I have a member something like this, okay, you can see it is like tempered on the lower side. We have a bigger you can see size here, then it is like decreasing. So we could also have different type of member. So if I have such type of member which is like changing its geometry along its length, so how we can actually model these two members, so we are going to see that as well. Okay, start करें इसको जी. May I start it?
Yes, sir.
Okay, so again, lecture content, we are going to start with some 2D problems of truss above and then some 3D problem again, and we will see some non-prismatic member modeling. And again, in the last, I will give you some class tasks, some assignments, some question, and you need to make the report for those examples or problem. So let me just directly start with this problem. Okay, so you already know, familiar with the truss type of structures. So here we are going to see how we can actually model a truss type element or problem. So let me just directly solve this problem. So here you can see the element section is given. It is 12 W12 by 14. It is a steel eye section, something maybe like this. Okay, something maybe like this. Okay, and now you can see the geometry of this truss. As you can see, we have this point A. So again, you need to repeat all those steps once again. So again, what was the first step? First step kya hoga? You need to
Understand
understand the problem concisely. Point A, B, C, the different lengths. You can see 20 feet. You can see the height is 20 feet, and these different joints. And the important thing are also these different type of loading, as you can see. So I think it's a very simple problem. You can see the global X and global Z here as well. So again, it is a 2D problem. Okay, so this was our first step. So in the first step we have understand the problem. What is the next step? फिर क्या करूँ, आप मुझे बताएं.
grid lines.
Grid lines.
The next step, I specify the grid line. So you tell me how many grid line in the X, in the Y, and in the Z I will need. Shaba बताएं.
In the X, 5 in the X.
In the X direction, I will be needing how many grid line? 5.
5, sir.
5. Or in the Y?
Sir. 2.
1.
In the Y,
1.
In the Z?
Yes, sir. Y.
Need
2.
just Z2. For example, Z1.
Z2.
And this is, for example, Z2. And the spacing is, you can see here, the spacing between the X grid line is just 20 feet.
Constant,
and the spacing between the Z is also
20 feet.
ठीक है जी. So let me just directly go to SAP and let me just इसको solve करने शुरू कर देते हैं. Okay, is it visible? SAP आपको नजर आ रहा है? जी नजर आ रहा है आपको?
Yes, sir.
Yes, sir.
Okay. So
Yes,
you already
sir.
know the steps. So we are done with our step number 1. We have understand the problem and we have specified the number of grid line in the X, Y, Z direction as well as their spacing. So let me just go and start like modeling it. So let us go. We already know about the section. This is actually, you can see this is actually a steel section, W12 by 14. We will choose any material property for that. So let me go. So I will click File, New Model. Okay, here again, you can use this 2D truss template for that, but again, we will use the grid only option to make a generalized problem. So here now you can specify the number of grid line in the x direction, number of grid line in the y, and number of grid line in the z. And you can also specify the spacing, but again I had did a mistake. I need to change the units to, you could say, Gibbs feet, because you need to know the problem here. The length are in feet and the load are in Gibbs. So you need to confirm the units. Okay, then you can go again, file, new model, again grid only. Here I can specify 5, number of grid line in the x direction, number of grid line in the y, and number of grid line in the z are 2, and the spacing between the x grid line is 20. It can be 1, and this is also 20. So I want to start my origin from the 0 position, so I can just OK. So here now you can see that grid line that we have specified. G. So we are done with our step number 2. Now what I do in the step number 3? Tell me.
Material, sir.
Material properties.
We क्या करूँ? Material. So next we need to define the material. So let me just go to define and material. In the material, you already know these two material will be always there. So let me just use this default material FY60. If you go to modify show, so you can see the grade, the unit weight, and the models of elasticity and all those things. So let me just use the same material again. If for your problem, if the material properties are changed, so you can change the material of this, or you can just add new material and specify your own material properties. Okay, so let me just use and assume that I am using this N992 FY60 50. Okay, so let's suppose we are done with the material. So what will be the next step?
Section.
We need to define the section. So again, here in this problem, we got this for 12 W12 by 14. So again, for this member, you need all the properties. So again, if you don't have those properties, the SEP 2000 can give you an option to import it. So for this problem, I'm going to import this W12 by 14 so that I can have its correct properties. So how we can do that? I already discussed that with you as well. So I can go to define. In the define section properties, and then frame section. If I click on it, this window will appear. So right now I don't have any section, so I can add a new section or import a new section. For this problem, I want to import it, so I will just click on it, and then you can specify which type of section, material section you want to import. I want to import a steel section with this I flange. Here, this window will appear. This is the installer window, installer folder of the SEP 2000. So here, if you just go to the down here, you can see this sections.pro. If you just open this file, so this window will pop up, and here you can see different HP section, M section, S section, and if you just go down, so you can see this W section. Here I want the W12 by 14. So here, can you see this one? ये आपको नजर आ रहा है जी? So this is W.
Yes, sir.
12 by 14. If I just click on it, so its properties will be visible to me, and I can assign any material. Again, if I have make a chain material, you can send it. Again, you can set the modifiers, you can set the properties, all those, and you can see the property. The cross section area is this, the moment of inertia about major axis, minor axis. All these properties for this section are already given to you. Okay, so this is how we can actually import a section. So here now you can see, you can even modify this thing if you want. Just okay it, okay. So now we are done with our
Section.
section as well. So again, we have understand the problem. We have specified the X, Y, Z grid line and spacing. We have defined the material. We have defined the section. अब क्या करूं बताएं?
Loads.
Now what I need to do?
Assign joints.
Draw the frame.
So load patterns.
Load patterns and
नहीं,
Frame draw करना.
load types.
चले let us draw frame को हम draw कर लेते हैं, and after that we are going to assign the loads. ठीक है? So you can see the geometry of the this problem, so it can be easily drawn. You can just draw it. For example, I will just go here, draw frame cable. So here you can see the section W12 by 14 which I just created. It's now visible. ठीक है जी? Again, the line object type is straight. I want to draw a straight object. The section is W12 by 14, and here you can see the moment release. So you already know, last time I discussed this with you. By default, the moment release is continuous, and by continuous mean that the moment and all those forces and moment are going to be transferred from one member to another member. But you already know that this is a truss problem, and in truss problem every joint is actually a pin connection, so that there will be no moment transfer. So in order to do that, what you can do, you can convey this thing to step by two ways. One way is that from the start you just select this pin connection and then draw the elements, draw the model. So from the start you will be having those pin connected elements. But if you didn't do it, let me just do the other way. Let me just assume first continuous, and later I am just going to change the properties from the continuous connection to moment release to a pin moment release. Okay, so let me just use this continuous for the time being, and later I'm going to change it. So now I will just go, I will just draw the member something like this. Okay, for example, this and these vertical members. I am drawing correct. सही बना
Yes,
रहा?
sir. Yes, sir.
जी सही बना रहे हैं जी. Okay, and then you can just draw it like this and this vertical member. Okay, so I think we are done with the drawing of this element. But again, you should know that the connection between this element and this element, or this element or this element, or the connection of this element and this element, or this, all these are actually continuous or fixed type connection. Okay, they are going to transfer those moments. So let's suppose we are done with this modeling. In the next step, what we need to do, we need to assign the support condition. So if you just go to the problem, so here on this side we have a pin connection, and on the other side, on the E side, we have a roller connection. So very easy, I can just select this one joint, and I can go to assign, I can go to joint, and I can go to restrain. So I just need a pin connection. So pin connection means that it will resist the vertical force and horizontal force. So horizontal is translation 1 and vertical is translation 3. So I can just uncheck this one. Okay, and if I just apply, so you can see I just get a pin connection here. Similarly, at this point, I have a roller support. Roller means it can only resist vertical loading in the Z direction. Okay, so I can just go to assign, go to join, go to restrain, and in the restrain, I will just check the translation 3. You can also select any of these, but I'm just using these options so that you can also have the idea what these options is for. So I can just use this, check this translation 3, mean that in the vertical direction, it will going to resist the load. So a roller support is such a support which can resist the loading in the vertical direction. So if I just click OK, so now you can see a roller support has been provided on this end. Okay, ji, we are done with this. Okay, so what will be the next step? Up next क्या करूं? जी, anyone?
Sir, the moment release.
Moment release कर लेते हैं. So for that, this is very easy. Just I will select all the members, something like this, all the members you can see here, and I will just go to assign. I will go to frame, and in the frame, if you go, what's this? Releases and partial fixity. If I just click on it, so I already discussed this window and this partial fixity in moment releases with you. What I want to do, I want that for each of these member, both the I end means both the start end and both the end should have those moment releases. So what I will do, I will just I will just check this moment M3 and M2 for this member, and I will just click apply. So now you can see this green color dots actually shows that the moment releases has been applied to all these members, and they will only transfer the axial loading among these members, but no moment transfer. Okay, just okay.
Sir, ये कहाँ से होता है सर? एक बार please sir.
अच्छा, आप सब तमाम members को आप select कर लेंगे. You will go to assign, you will go to frame. In the frame ये क्या लिखा है? Tell me. ये क्या लिखा हुआ है? What's this?
Sir, release partial
fixity.
fixity.
Release
जब आप क्लिक करेंगे तो from here you can release any of the frame actions. ठीक है, if you want that this frame shouldn't be able to resist any axial load in the start or in the end, then you can use this one, or shear force or bending or torsion. But here for a pin type connection, we already know pin connection can resist axial load, can transfer those axial tension and compression forces, but cannot resist the moment and torsion, those etc. So that's why I just releases M2, M3. I didn't release the torsion because we already know this is a 2D analysis. ठीक है, so this is how we can do that. जी, अब समझ आया आप लोगों को?
Yes,
If
sir.
you want to see the undeformed shape, you can just click here, show undeformed shape, and it will show you the original shape of the or original configuration of the model. So we are also done with this. G, what's the next step? Ab kya kare?
Load the sir.
Now we
Load
can apply
the
load. So if you see the problem, so here we have these three loads, 3-point load, three kips at this H node, G node, and F node. So I can just directly go. I can just select these 2 points, these 3 points, sorry, and I can directly go to, let's suppose, assign, and I can just go to join load. In the join load, either I can apply displacement load or forces. So it is actually a force. So I can just apply force load. So again, same procedure. I have just only one load pattern, dead load, and I want to apply the loading in the global XYZ direction. Okay, and this loading will be in the Y direction, but negative Y, because I want to, because the loading direction is negative to the Z direction. So I will just say 3. I have selected these 3 nodes and I am applying the node to each point. Now you can see that a 3 kips load has been applied to this point H, G, and GH, H, G, and F. G, is it clear now?
Yes, sir.
Is it clear? Okay.
Yes, sir.
You already know if I'm going to analyze this problem. So in the analysis, we will also consider the weight of the member. This is the self weight. But for this problem, I only want to see the analysis or the axial forces in these member because of the external loading only. So that's why I will just go in the define, in the load pattern. For the dead load case, I will just assume 0. This 0 means that the self weight of the member will not be calculated.
Yeah,
Okay?
load it.
So इसको edit करें, modify load pattern, and okay. So almost we are done with all the steps. Okay, we have understand the problem, we define the grid line, we define the material, we define the section. After section, we draw the model, we assign the boundary condition, that is restraint. Then we also apply the partial fixity to all the frame members so that they can only transfer the axial forces, no moment. Okay, and I think we have also we are done with all the steps, and we are now ready to do the analysis. जी analysis कर ले?
Yes.
Yes sir, कर लें.
Okay. I will just unlock model को मैं do not run करूँगा because it is a static analysis. So I will just model do not run, will dead load will run. So if I just run it, you can just, for example, save it by any name. For example, let me just make a folder for it. Okay, let's suppose this is the, now you can see this is the displaced position because of the loading. Okay, now if you just go here, these are display option. If I want to display the node levels or the frame levels, so I can just apply this. Okay, in the deformed shape it doesn't show. Okay, remember, it will only show in the undeformed shape. So now here you can see this is our, for example, frame 1, frame 2, frame 3, frame 4, and then this is frame 5, frame 6, frame 7, and frame 8. Let me just notes ko main hata deta hu so that they are visible, more visible. Now you can see from here you can locate the which member has which position or which numbering. Similarly, these nodes 1, 2, 3, 4, 5, 6, 7, 8. We have total 8 nodes. So you can also specify the load position. Okay. So next, what we can see, we can display the displacement position, deform position. As you can see, this is the deform position for every node. For every node, this node will be have 0 position because this is a pin connection, so it couldn't displace in the X or in the Z direction. Similarly, this can displace in the X. You can see U1 is equal to 0.003 because it is a roller support. It can displace in the X direction, but the Z direction U3 is 0. Similarly, U2 is also 0. For every joint, you can locate these displacement. Okay. Similarly, if I just go to the forces and stresses, so here you can see, if I just click on the axial force, the load pattern is dead load. So you can see all these loading, these tension and compression loading will be visible to you. You can also make visualize with the values. Okay, but if you see any other load, any other load, moment 3 तो होगा, share होगा, ठीक है. देखिए moment, there will be no moment in these members, ठीक है. This is M33. अच्छा ये very small 0.2, ठीक है. Because of the, you can see only axial load, predominant loading is actually those axial loading, as you can see here. We can visualize, this is one way of visualizing the axial or the shear or the bending or the displacement position, displaced position. We can also make visualize all these results, that is the joint displacement results or the member axial force result through a table. For example, let me just quickly show you. Go to display. In the display, ये क्या लिखा हुआ है? What's written here?
Show
Show
table.
Tables.
Show table. Click on it. So you can display all sort of information that is available in the modeling stage and in the analysis stage. So we are not right now. I'm not interested what are the different information or data available for the model definition, but I am interested what actually happened in the analysis. So you can see in the analysis, you can see run information. In the run information, you can see those. If you go to the joint output, so you can display the joint displacement, joint reaction, joint masses, whatever you want. For example, I want to see the joint displacement, every joint displacement. Okay. So before that, let me just okay, let me just make it okay. So now you can see it here, and let me just also show you. Okay, let me just click it. Let me just show you the joint labels, not the frame labels. Okay, so that you should have the idea. Now you can see the joint label 1, 2, and 3, 4, 5, 7. All these. It's depend upon the position, the numbering after which we have just created those joints. So, for example, these have the joints. I want to see the displacement of all these joints. So, what I can do, I can go to display. I can go to show tables. In the show table, as you can see, we have analysis result. In the analysis result, I am interested, for example, right now in the joint displacement. So just make it okay. So now here you can see total we have 8 joint. As you can see, 1, 2, 3, 4, 5, 6, 7, and 8 and 8. So you can see total we have those 8 joint. And for here we have this load dead load case. Here you can see now these 3 types of translations and these 3 types of rotations or rotation. So here you can see the joint one, which is actually a pin connection. So you cannot be having U1, U2, or even U3. But joint 2 here, this is joint 2. Can you see this? This is joint 2. So after the application of this 3 kips load, 3 kips load, 3 kips load, this joint has been displaced in the U1 direction by this amount, in the U2 direction by this amount 0, and in the U3 direction by this amount. Okay. Similarly, if you go to joint number 3, you can see the displaced position in the X, Y, and Z. That is in the U1, U2, and U3 U3 direction. Is it clear? ये बात clear होगी सबको?
Yes, sir.
Similarly, for example, if I want to see the axial forces, so one way is that I just show the axial forces over this figure, maybe something like this. Okay. But if I want to see the axial forces values, through using a tabular form, so what I can do, I can just go to again display, again go to show tables. Here previously, in the analysis result, I want to show the joint output displacement. Here you can see the reaction. Let me show you, let us see the reaction as well. यहाँ पे at this pin support, what are the reaction, and at roller support, what are the reaction. It can be also displayed something like this, because we have only 2 support, 1 and 5. At 1 we have as you can see, as 1 we can have, because there is no vertical loading, horizontal loading, so that's why at this we have horizontal 0. You can also make displayed through these arrows. For example, you can go to display and joint and arrows. Okay, now you can see total load is 9 kips downward, so 4.5 kips is taking this side, because this is a symmetrical structure. So half load will be taken by this one side and half loading will be taken by the other side. And as there is no any horizontal loading, so this X component, horizontal component at this pin joint, at this pin correction is actually what? 0. You can also make visualize these these, like I discussed with you, through these tables, show table or joint element output. Okay, let me just make it. So now you can see 4.5 feet in the F3 direction, you can see, and F1 means in the high X direction, and F2 in the Y direction. They are 0. Okay. Similarly, if I want to show the axial forces in these member, the forces in this member 119192 and all these members, let's suppose, how we can display. So again, one way is this: you just show the axial force diagram, and the other way is just go to display, show tables. In the show tables, now I don't want to see the result of the join output, but the result of the element. So frame output or object, you can see it here. You can hear element forces, element stresses, or joint forces. Here I'm only interested in the element forces. So if I just click OK, so now here you can see the forces. Now we are only interested in this P load. P is actually the axial load, V2 is shear, V3 is shear, T is torsion, M2 is moment, M3 is moment. So all other three you can see are coming zero, but we are mostly having this axial loading. Negative means compression, and positive values will mean that they are in the member are in tension. Here you can see one thing is very important here. Here you can see frame element 1. This is frame element 1. Can you see this? Let me just. This is frame element 1, as you can see. And the values, this is in compression with a value of 6.35. But here we can see three values for this: 1, 2, and 3, because this element has been divided into three sections. Okay, so after for each section they will give you the value. Okay, so out of this section we will just consider only one. Okay, the better way is that you just copy all the data and you just go to some, for example, Excel sheet. You just, for example, paste it there. Copy new. Okay, there is a view, edit. Yes, you can also export all table or display editor, और to Excel को हम इसको export भी कर सकते हैं. Okay, this is actually an evaluation version. That's why the data cannot be copied from here. If you use a licensed version, then all the data can be copied to an Excel sheet, and from there you can just get the respective element forces. जी कुछ समझ आया इस प्रॉब्लम की? जी, have you understood this?
Yes, sir.
Any problem in this problem? Any
No,
question?
sir.
No,
So
sir.
let me just now directly go with this. I have solved this problem. So again, they are also discussing the same steps again, just for you. So again, we will be a pre-processing stage, analysis stage, and then post-processing stage. So now they are again, first they have defined the grid lines. After that, you already know you need to repeat all these steps, which we have repeated in the previous sections, previous class. You need to define material, define section, load pattern, load cases, load combination, and then drawing, etc. So you can also see they are actually drawing these. They have draw this element, this frame, this truss element, truss problem. Then they have provide these internal releases, as you can see. So mostly for a 2D problem, we just release this M22, M33. But if you have a 3D problem, then we can also release the torsion so that they cannot be twist about its longitudinal axis. Once you're done with that, this is the mounting phase. Then you can start analysis, and then you can see the result as well. कर लेंगे इसे?
Yes, sir.
Any problem in this 2D truss problem? Truss example, कोई problem है?
No, sir.
Okay, आगे जाएं. Let us solve this one. Another problem. Can you see this problem?
सर ब्रेक कर ले.
Break करना है?
Yes sir.
Yes, sir.
Okay, children, let us break for